Hello friends, phenomenal day, right? How true. Welcome to our lectures today. On our lectures today, we are going to be continuing our series on binomial theorem. And in studying binomial theorem, we're going to be studying a very exciting concept today, which is the combination. What is the combination? The combination can be defined as per mathematics as the selection from a range of alternatives, right, without taking into consideration the order of selection. It is the selection from a range of alternatives without taking into consideration the order of selection. So it's what you would term a random selection. What is then the formula for the combination? We are studying mathematics, so there has to be a formula for these sorts of things, right? How true. So the combination is given as n combination r equal to n factorial. This is why in the first and the second video we had to study factorial in depth, right? Because we will need factorial to understand the combination. So this gives us n factorial divided by n minus r factorial multiplied by r factorial. How true. This is the formula for the combination. Now, it's worthy of note right here to tell you that this symbol is not the only way of representing the combination. The combination can also be represented in this form: n combination r. So in case you see this in your textbook, please don't get it confused, okay? This can also be n combination r. Whichever one you choose to apply, the same rules apply. Okay, now let's take some classic examples and let's see how it goes. 5 combination 2. If we should compare our question right here with the formula, you would understand that 5 represents n and 2 represents r, right? So wherever we see n, we can slot in 5, and wherever we see 2, wherever we see r rather, we can plug in 2. So this gives us 5 factorial, because the formula says n factorial. Now the formula says n minus r factorial, so that would be 5 minus 2 factorial, because 5 represents n and 2 represents r. So let's plug that in. 5 minus 2 factorial. 5 minus 2 factorial multiplied by r factorial. Now r factorial, so 2 represents r, so that will give us 2 factorial. 2 factorial. Let's take the difference at the denominator and let's see how it goes. 5 factorial. Now at the denominator here we have 5 minus 2, so that gives us 3, right? Very true. 3 factorial multiplied by 2 factorial. Now in opening up 5 factorial from the previous video, you would know that this would give us 5 times 4 times 3 times 2 times 1. Very true. Now divided by 3 factorial, we start from 3 and we decrement down to 1, so that will be 3 times 2 times 1, right? Very true. So 2 factorial also, now we are multiplying by 2 factorial. In opening up 2 factorial gives us 2 times 1. How true. Very true. So let's cancel out as per division and let's see how it goes. This goes, right? 2 here 1, 2 here 1, right? 3 at the denominator cancels this 3 as the numerator, right? Now there's a 2 at the denominator, right? This 2 right here. So 2 here 1 and 2 into this 4 gives us 2, right? Very true. Now 5 combination 2 in the end gives us 5 times 2, and in the end that gives us 10. How true. Very true. I know someone is thinking, why did we just multiply 5 times 2 and save ourselves with stress of going through all that? Okay, I'm gonna go ahead and tell you, don't do that. Okay, don't do that. That would be something, but it would definitely not be mathematics. That is not mathematics. Okay, now moving on, let's play with another example and let's see how it goes. Now 7 combination 3, 7 combination 3, 7 combination 3. Now 7 combination 3, we can evaluate that, right? If we compare with our general formula right here, we would understand that 7 represents n, 7 represents n, and 3 represents arrow, right? Very true. So in solving this, we're going to have 7 factorial, 7 factorial, how true, divided by, now we're going to take the difference, right, between 7 and 3. So that will be 7 minus 3 factorial. The general formula says n minus arrow factorial, right? So since 7 is n and 3 is arrow, so we're going to have 7 minus 3 factorial, right? Multiplied by, according to the formula, arrow factorial, and arrow is 3, right? So that gives us 3 factorial. Very true, very true. Now let's take the difference at the denominator and see how it goes. 7 factorial now, 7 factorial divided by, now 7 minus 3 gives us 4. That will be 4 factorial, 4 factorial, multiplied by 3 factorial. Now someone might be thinking, right, do we always have to evaluate 7 factorial as per 7 times 6 now, times 5, times 4, times 3, times 2, times 1, all the time? Okay, let me help you out with a little trick here. You don't always have to get down to 1. You can stop at any of the numbers at your denominator, right? So let me choose 4 now. Let me explain that whole piece and let's see how it goes. If I were to write 4 factorial, that would give us 4 times 3 times 2 times 1, right? 4 times 3 times 2 times 1. If I were also to write 7 factorial, that would give me 7 times 6 times 5 times 4 times 3 times 2 times 1. If you observe carefully, you would notice that all elements of 4 factorial are contained within 7 factorial. So we can divide right through here, and we have that all elements contained within 4 factorial are also elements contained within 7 factorial. So we can choose to rewrite 7 factorial as this. 7 factorial as 7 times 6 times 5 times 4 factorial, right? Since all elements of 4 factorial are contained within 7 factorial, we can choose to write 4 factorial within 7 factorial, right? So let's put that in our question and let's see how it goes. So this gives us 7, right, times 6 times 5 times 4 factorial, 4 factorial, how true, divided by 4 factorial, multiplied by 3 factorial. The question on your mind might just be, can factorial cancel out factorial? And you are very right, it can cancel out. So 4 factorial cancels out 4 factorial at the numerator, right? And this kind of simplifies our problem, right? It simplifies our work. So this gives us 7 times 6 times 5, right, divided by 3 factorial now is 3 times 2 times 1, 3 times 2 times 1. So in the end, 2 here 1, 2 into 6 gives us what? 3. And 3 here 1, 3 into 6, 3 rather, 1. So in the end, we are left with 7 times 5, and 7 combination 3 gives us 7 times 5, which gives us 35, right? How true. That is why I said you cannot just go on ahead and multiply 7 times 3 as per what happened with the 5 combination 2, right? Now let's play with 1 or 2 more examples, then we call it a day. Now 4 combination 0. How do we handle this whole piece, right? So comparing with our general formula, which says n combination arrow equal to n factorial divided by n minus arrow factorial multiplied by arrow factorial. This would be our general formula. Comparing with our formula, we see that 4 represents n, right? 4 represents n, 4 represents n, and 0 represents arrow. So wherever we see n, we put in 4, and wherever we see arrow, now we substitute 0. So this gives us 4 factorial divided by 4 minus 0 factorial multiplied by 0 factorial. So in the end, we are left with 4 factorial. 4 minus 0 at the denominator now still gives us 4 factorial. And in our previous video, we were able to prove that 0 factorial gives us 1. So guys, check out that video if you don't understand that, okay? 0 factorial gives us 1. So we have that 4 factorial cancels out 4 factorial, and in the end we are left with 1 over 1, which gives us 1, right? 1. How true? Very true. So in the end we are left with 1. Now this gives us a general rule for the combinations, right? So wherever we see n combination 0, the answer would always be 1. This is a general rule as per the combinations. The answer would always be 1. How true? So what happens is this: if you see 5 combination 0, 7 combination 0, 10, 100, a million combination 0, your answer would always be 1, right? It's a general rule as per the combination. One more example: 3 combination 3. So comparing with our formula, 3 represents n, and 3 at the base here also represents n. So anywhere we see n, we substitute 3, and anywhere we see arrow, we also plug in 3. So we have 3 factorial divided by 3 minus, since n and arrow are both 3, so we're going to have 3 minus 3 factorial multiplied by 3 factorial. This gives us now 3 factorial at the numerator. Now at the denominator we have 3 minus 3, which gives us 0 factorial multiplied by 3 factorial. So we know that from our studies that 0 factorial gives us 1. So this gives us 3 factorial over 3 factorial. And your guess is as good as mine, guys. 3 factorial cancels out 3 factorial. And in the end, we are left with 1. How true? How true? So this gives us another general rule for the combinations. Wherever and whenever you see n combination n, this will simply mean that the n is equal to the arrow, right? So this would always give us 1. This would always give us 1. How true? This brings us to the end of our studies as per the combination, right? Why don't you click on the next video, and we're going to be studying binomial expansion in depth, right? We're going to take an in-depth study of the binomial expansion. Please do like our video, please do subscribe to our channel, and please do ring the notification bell to get more of our content. A wise man once said, make your brain work. It will sweat, but make it work. Then it will reproduce till you become the envy of all those around you. Make it sweat. It will produce fruit for you. Thank you so much for watching. See you in the next video.